So you could probably figure some of these out just like this one. Most of you came up with, or you would come up with eventually, 8 and 4, right? Or 4 and 8. Close and undo. There we go. And you can prove that just by writing it down. Well, 8 plus 4 equals 12, and then 8 minus 4 equals 4, and this looks strikingly familiar to what we just did. You can just take out 8 and put in x, take out 4 and put in y. So we're purposely using some easy numbers right now. Same thing here, 8 minus 4 would be like x minus y. So one thing you'll find if you groaned about, oh, you just saw a bunch of words on a math worksheet right now, that these equations are actually probably some of the easiest to solve. These word problems are some of the easiest because we already know the format of our equations. This looks just like what we've been doing. The x and y are on the left. It equals some number, and we know how to solve this. So go ahead and solve this and just prove that you can do this with algebra as well. Now, of course, in the future, you can imagine if we're doing stuff with the stock market, and these numbers are like, you know, the stock market's getting ready to hit 28,000 right now. It's at 27,982 or something like that. So it's kind of easy with simple numbers, but if we start putting numbers in the 12,000s or fractions, we would actually have to do the algebra. There'd be no just guessing it and getting it right. So keep that in mind, that that's why we need this method. It's nice and easy with easy numbers, but it doesn't mean it always has to stay that way. So just as predicted, we get x equals 8, like we got here just by doing guess and check. And like we've done before, we can plug it into either equation, show your work, as always, and we get already what we expected, a y equal to 4. Okay? So it's not too bad, right? And you know for today, we're going to have two equations with two variables. Just keep that in mind when you're coming up with your equations. It's always two equations, two variables. That's what we start with in Algebra 1. When you guys go to Algebra 2, you'll do 3 equations with 3 variables. You'll do the x, y, and z axis, 3-dimensional graphing. Right now, we're just starting with 2 dimensions. All right. All right. Now, can you use this to help you with number 2? Yeah. So give that a shot. Let's try it just using algebra and see how that goes. So the one above was the value of 2 numbers sum was 12, right? So we had 2 numbers sum equal 12. So how would you change this in order for it to work for number 2? Now, it's pretty basically the same thing, right? Instead of equals 12, here's 13, right? So you can use these as examples for other problems. It doesn't have to be the exact same problem. These are all related in that they always come out to 2 equations with 2 variables each. Okay? And this time their difference is 3. Last time the difference was 4, and we got x minus y equals 4. How would we change this for this equation? X minus y equals 3. So, and the rest we already know. Okay, go ahead and finish that up, solve that, and get your 2 answers. Let's not forget, I actually forgot on this first one. Let's write our answer as a coordinate still. X comma y. Always alphabetical. Okay, x comma y. Well, so 8 comma 4. This is technically the answer. It's always an ordered pair. Okay, but finish up number 2. I'll give you a few minutes, and you'll find these check a little bit easier because we got 2 numbers, and we're trying to see, well, do they add up to 13? Yep, they check out. 8 plus 5 is 13. Do they subtract to 3? Yep, 8 minus 5 is 3. So the check on here is pretty quick. All right, so let's step it up just a little bit and include maybe some coefficients, you know, some numbers in front of the variables like we had in yesterday's homework. So here we go. At the game, Liz buys 2 large drinks and 5 churros for a total of $31. Now keep in mind, the format of your equations are always going to be like this. So think of the two things that you're buying as the two variables, or the two numbers, right? So what two things are being bought? All right, so drinks we can call D or X, whatever we want to call. We can use an actual letter that represents it so we don't confuse them later on. So we got 2 drinks. What does and represent mathematically? Plus 5 churros. 5 C for a total of equals $31. So like I promised before, the translation from the words to the equations is actually very simple because it's one of the few types that actually translates perfectly from left to right. As you read it, if you just write down what each of these parts mean, 2 large drinks and 5 churros for a total $31, they mean their translations are perfectly placed right above there. Okay, so not too hard to come up with the equations. And just do that for the second one. Go ahead and do the second one, see what you get. All right. 2 drinks again, and 2 churros, total of 22. All right. What do you think? Is this doable? Yes. These are not the word problems you might be afraid of from the past. These are very doable. Okay? And if anything, it'll give you some good confidence because you can move into algebra with word problems that, okay, I can do this attitude. Not going to scare you off. All right, so the question becomes, now that we translate everything, how should we solve? Multiply the top by -1 or the bottom. Either way, you can go either way. It does not matter. Because we just need one positive 2D and one negative 2D. So it doesn't matter which one you do, totally up to you. I do the bottom. Top stays the same for me. There we go. So you notice this is not really different from what we did on Friday and over the weekend, right? Pretty much the same thing. So 5 minus 2 gives us 3. 31 minus 22. 9er. 3 times what equals 9? That'd be 3. So 3 churros, like so far. How much does a drink cost? Okay. So let's go back to either equation. I'll use the bottom one. 2D plus 2C equals 22. So I took my C, substituting it in right here. This C right here is this C right here. All right, so we got 2D. 2 drinks plus the cost of 3 churros, which comes out to $6, right? Each churro's $3. We got 2 of them, so $6 in churros. All that adds up to $22. So how much just for the 2 drinks? So subtract 6 on both sides. The 2 drinks cost $22 minus $6, which is what, 16? Yep. So what that means, how much does 1 drink cost? 2 drinks cost $16. 1 drink costs $8. Okay. So, and if you've noticed this at any restaurant or movie theaters or whatever like that, it's the drinks where they make a killing. That's where they make most of the money, right? They take a soda and they charge you $3 for it when it costs them 2 cents to fill it up. Right? Soda's very cheap. Right. What order should we write the answer in? So why are these ordered in this way? Why is it X and then Y? Alphabetical. So what should we do here? Always alphabetical, regardless of what order you solve for. No matter what. Always alphabetical. That keeps us all having the same answer in the same way and not, arguing over, no, it's 8-3, it's 3-8, like we just do alphabetical no matter what. We always have the same answer that matches. Okay, so looking at all these, you can probably see different problems coming out that are basically the same process. So it's not really about anything new, just practicing and seeing them in a new way. Let's see here. So let's pick one on the back that we want to set up. Let's set up a few on the back. So that way we have a little bit of the front, a little bit of the back done. 7 and 9 maybe, yeah. Okay. So school A is filled 8 vans and 8 buses with 240 students. So what's the equation? 8V, 8 vans and plus 8 buses is 240. 8 vans plus 8 buses all together add up to 240 students. Okay. School B, we had 4 vans and 1 bus. You could put a 1 here if you want, and that equals only 54. Okay. So the numbers are a little bit bigger, but it doesn't change how we solve it or the difficulty of the algebra. It's the same process. At any time, if you need a calculator, you can use that if the numbers get big and you just don't want to make a mistake with arithmetic. Now, you notice here, how can we cancel out a variable here? So what number cancels out with positive 8? What number would cancel out with positive 8? Yeah, we need a negative 8 here, right? We need a negative 8 here to cancel out with positive 8. So kind of like what we just did on that last problem, number 10, 29. What can I multiply by to get a negative 8? Negative 2. All right. That's the whole reason we're doing this, is figuring out this number because it needs to cancel with positive 8. I need a negative 8. The only way to get negative 8 from positive 4 is to multiply it by negative 2. And the rest of it, just make sure you multiply each one of these, right? So minus 2b, right? Minus 108. Okay. And the top will stay the same. So if anything, the numbers might get a little larger, but it doesn't make the problem more difficult. The algebra is identical. Right? So we'll have the V's will cancel out because we set it up so we got positive and negative, right? And here we have 8 minus 2b, so 6 times what? And then 240 minus 108. So 240 minus 100 is 140. 140 minus 8, 132. So 6 buses take 132 students. So each bus six goes into 13 2 times, remainder of 1. So 6 goes into 12 2 times, which means each bus can carry 22 students. Okay. So if you're going to get stuck, this is probably the way and place to look is, are you choosing the correct number so it cancels out? Okay. And you're going to get as much of this finished when you walk in the door already done. Okay. That's your task. You can go to the homework center after school today. You can go to the math lab after school today. You can watch a ton of videos on how to do these. Right? So there's lots of help. You can help each other. You can talk after school, meet after school. Make sure we got a lot of these done when you walk in the door tomorrow. Okay. And we'll see you then. Please put the computers underneath the desk.